Hi there and thanks for joining me. In this video we are looking at the AQA GCSE Mathematics Foundation Tier Paper 2 Calculator paper from Thursday 6th of June 2019. We are simply going to answer every question through the paper. Let's start then with question 1. It asks us to circle the number that is 1 less than a cube number. Well, don't forget, a cube number is found by multiplying a smaller number by itself 3 times. If you're not sure, well, these are not very large numbers, so start with a low number. Maybe start with 2. So you would have 2 times 2 times 2. That's 8. 1 less than 8 would be 7, so that can't work. Let's have a look at 3. We have 3 times 3, that is 9, times 3 is 27. Take away 1 from 27, we get 26, and there it is. Our answer is 26. Question 2, circle the fraction which is equal to 0.25. Well, first of all, we need to know that 0.25 is equal to 1/4. So we need to look at these fractions to find out effectively whether we can simplify them down to 1/4. Now 1/40 doesn't simplify, so it can't be that. 2/5, again, we can't simplify that, so it wouldn't be a quarter. 4/100 does simplify, but if we simplify the top and bottom, we end up with 1/25, so that doesn't work. Whereas 3/12, we can divide the top and bottom by 3, and we get 1/4. So again, there's our answer. Question 3, we have a number line, and we're asked what is the number that should be at A? Well, let's have a look at this. The number line goes from 3 to 4. So we need to know what each of the little sections are between 3 and 4. Well, look at the number of steps. It goes up 1, 2, 3, 4, 5 times. So actually, it has gone up only 1, but that 1 is being divided into 5 stages. So if you literally go 1 divided by 5, you'll find that each of the steps is 0.2. Therefore, if we add 0.2 to each stage here, to each division, we get 3.2. That would then be 3.4. Therefore, A becomes 3.6. That's 3.8, and it all fits together with 4 on the end, so A is 3.6. And question 4, how many millimeters are equal to 3.27 meters? Well, 1 meter equals 1,000 millimeters. Therefore, we need to take the 3.27 and multiply it by 1,000. And if we do that, we get 3270. Question 5 is asking us which is longer, 3/4 of a day or 1,000 minutes. Well, I guess we need to find out how many minutes there are in 3/4 of a day. Well, 1 day is 24 hours, therefore 3/4 of a day is 18 hours. So 18, we know that there are 60 minutes in an hour, so we have 18 times 60, and our answer is 1,080 minutes. So our answer at the bottom here would be 3/4 of a day. It's 80 minutes longer. Question 6, part A, says use your calculator to work out 9.75 cubed divided by 1.875 plus 6.4 squared. So you're feeding this into your calculator. It may change slightly depending on the brand of calculator, but you can literally feed this in as a linear calculation because the BIDMAS thing, need not worry, we're doing the divide before we're doing the plus. So literally you can feed in 9.75, use whatever button allows you to make that to power 3, hit the divide and put 1.875, and you can find the answer to that first if you like, but you could also simply just add plus 6.4 squared onto it, and the answer you will come out with is 535.285. Now, many calculators do give the answer as a fraction. That's probably going to be an acceptable answer, but best to press the S to D button and get the decimal answer so you can write the digits that you see on your screen. I'm going to leave 6A on the screen here because 6B is asking us, is your answer to part A sensible? In other words, they're asking us to check our answer, and they're telling us how to do it. It says check by rounding each of the numbers in the first calculation here. So let's do that. 9.75 would become 10. So we would have 10 cubed. So that would effectively be 1000. We are then dividing that by 1.875, so that would round simply to 2, so that would be 1000 divided by 2, which so far 1000 divided by 2 we have 500. We're then being asked to add, well, 6.4 would round to 6 squared, so that effectively is 500 plus 36. Our answer is then 536, which if we go back to the answer in our first part, which was 535.285, we are very, very close to the correct answer. So yes, our first answer was sensible. So let's move on to question 7. We've been asked to complete a bank statement. So let's have a look at this. We have various dates, and the first thing we have is a starting balance with a space. So we're obviously being asked to complete the start balance. What we do know is that from the start balance on the 5th of April, we paid out a debit, so that's money going out. We paid out £189.34, which left us with £72.09. So to find out what the balance was, we have to add these two amounts together. In other words, we put back in the £189.34. If we add those two together, we have £261.43. So if you check your answer, 261.43 minus 109.34 is £72.09. Our balance then goes up from £72.09 up to £86.75. And we are told that's because we've had some kind of refund. So again, with a calculator, we need to find out what that refund is. So the difference between these two amounts, the amount by which the balance has gone up, must be the refund. And if we take 72.09 away from 86.75, we get £14.66. We're then asked for the total balance. Well, it was 86.75. We've now been paid 1430.29. Add that on, and we get a final balance of £1,517.04. Question 8, part A, tells us that the interior angle of a regular pentagon is 108. We have it on the diagram here. And we're asked to work out the sum, so the total of the 5 reflex angles at the vertices of a regular pentagon. So we are talking about these 5 corners, the vertices. We want to know the angles on the outside. So the first thing that we're going to do is use one of the angle laws, and that is the fact that angles around a point add up to 360 degrees. So we have 360 degrees minus 108 degrees. That must mean that the exterior angle is 252 degrees. That is for one of the corners. There are 5 of them, so we simply have to multiply that one angle by 5, and the total we get is 1260 degrees. In 8b, we have a little conversation going on. Omar asks Harry, how many lines of symmetry does a pentagon have? Harry assumes it's a regular pentagon. His answer is 5. And we're asked to draw the lines of symmetry on this regular pentagon. So take a little bit of care, and you will find that there is a line of symmetry going from the very top point through the center of the bottom here. I will try to draw this as accurately as I can, but you really need to be going through the center, which is opposite each of the corners. So one from that corner, one from that corner across to there, one from that corner across to the centre of there, and one from there right through to the centre of the opposite side on that side. So there are your 5 lines of symmetry. Part C, Omar then says, what if the pentagon is not regular? And we're given a set of options as to how many lines of symmetry there might be. The first one says there must be none. Well, it's certainly the case that if it's a completely irregular, a scalene pentagon with all the sides different, there wouldn't be a line of symmetry. So 0 is certainly an option. There could be 0 or 1. Well, 1 is also an option. Let's imagine you have a regular pentagon which has simply been stretched in one direction. With a pentagon such as this one, there would be 1 line of symmetry around about there. So there could be 0, there could be 1. There certainly can't be any number up to 5, because if there were 5, it would be regular, and we're told this one isn't. As to whether there could be 2, slightly more difficult to describe, but for there to be 2, it would mean one of these other lines was also a line of symmetry in some way. And that can't happen. If there were going to be 2, there'd actually be 5. So the only option you've got on here is that there could be 0 or there could be 1. 2, 1. Question 9. We have a bit of a story here. 56 customers have satellite television. They all have the basic package for £24.50 a month. We're then told that some have the sports package in addition for £27.50 extra, and some have the movie package for £18 extra per month. We have a frequency tree showing the numbers of customers. I've rewritten the question here because in the paper it's on the next page. But the question is, in total, how much per month do the 56 customers actually pay? Well, let's have a look at this. All 56 are paying £24.50 per month. So we're going to have to do £24.50 times 56. We then need to look at how many have the sports package. Well, these 35 don't, these 21 do. So they are paying £27.50 extra. So that's £27.50, and there are 21 of them. Let's move on to the movie package. Well, out of the 21 sports subscribers, 14 of them also have movies. But also in the bottom half, of these people who don't have sports, 8 of them do have the movie package. So we need to add these two numbers together. There are 22 of them. So £18 a month is being paid extra by 22 of the customers. The first thing we have to do is work out these 3 totals, and then we simply total them. So the total for the first calculation is 1,372. For the second calculation is £577.50, and the third calculation is £396. And if we add them together, our final answer is £2,345.50. Question 10. Zoe is thinking of a number, and we are told that 3/10 of 90 is equal to half of her number. And we're asked what number she's thinking of. Well, first of all, we need to work out what is 3/10 of 90. And to do that, first of all, we take the 90 and divide it by 10. Divide by the bottom of the fraction, and that equals 9. We then multiply by the top of the fraction. 9 times 3 is 27. But we're told that 27, a third of 3/10 of 90, is half of her number. So if 27 is half of her number, we have to multiply it by 2, and the answer we will get is 54. Question 11 gives us a graph. It tells us on a journey Laura sees 30 vehicles, and they're all cars, vans or lorries. She's drawn a bar chart to show us how many cars, vans and lorries she's seen, but we have to make 2 criticisms of her bar chart. Well, let's have a look to see what appears to be wrong. First of all, the bars are not equally spaced. That doesn't necessarily destroy the information it's given, but it looks wrong. Also on the bottom we have type of vehicle, which is okay, but then we have CVL. Well, we're not told what C, V and L stand for. A graph has to tell us clearly. This could have been done two ways. It could have been done with a key at the side here telling us what C, V and L is, or she could simply have written cars, vans, lorries along the bottom. Either way, it's not right. And I can see a third issue with this graph. In fact, we're told that she's seen 30 vehicles, but actually 14 plus 4 plus 10 only add up to 28. So she's actually missed 2 vehicles off the graph. Choose any 2 of these 3. Question 12. A drawing has a scale of 1 to 40. On the drawing, a bedroom is a rectangle measuring 10 centimetres by 18 centimetres. A kitchen has an actual area of 300,000 square centimetres. And we're asked which has the biggest actual area, the kitchen or the bedroom. So let's have a look at this bedroom. We have a scale of 1 to 40. Therefore, if one side is 10 centimetres, on the diagram, on the drawing, then we have to multiply that by 40 to find the real size, so that becomes 400. The other measurement of the bedroom is 18 centimetres, so again we have to multiply 18 times 40, and the answer to that is 720. So in order to find the area, it's length times width, 400 times 720, and for that you get 288,000 centimetres squared. So the bedroom is 288,000, the kitchen is 300,000, so it is the kitchen which is the larger room. Question 13. Here are 2 similar shapes, so they are different sizes but the same proportion. They're labelled A and B. It tells us the length of the edges in A compared to the length of edges in B are on a ratio of 2 to 5. It says the perimeter of A is 210, so we need to know the perimeter of B to answer the question. A couple of ways you could do this. First of all, if you have 210, we know that has a value of 2. So if I divide it by 2, I'll end up with 105. That gives me a value of 1. I'm looking for a value of 5, so I can multiply that by 5, and that will give me 525 millimeters, and that's the answer. Another way of looking at this is if we look at the ratio, which is 2 to 5, if we simplify this in terms of 1 to n, we would have to divide both sides by 2, so we'd have 1 to 2.5. In other words, B, each edge is 2.5 times bigger than 1, so we would simply take the 210 and multiply that by 2.5, and again, same answer, 525 millimeters. In question 14, we are completing a Venn diagram, and here's the information we've got. There are 135 passengers on a plane, so that is our total universe, total number of passengers on a plane. 3 of the passengers in business class, the left-hand circle is business class, 3 of the passengers in business class are flying for the first time. And in total, there are 15 passengers in business class. Let's put this part of the information into the diagram. We know in total there are 15 people in the business class, and the business class is this left-hand circle. But out of the 15, 3 of them are first-time flyers, which is the right-hand circle. So that 3 have to be the people who are in business class and first-time flyers. That's 3 out of the 15, so the other 12 business class go into that circle. A quarter of the passengers not in business class, well, we need that number. So if there are 135 passengers and 15 of them are in business class, take that away, it means there are 120 other passengers. It tells us that 1/4 of the passengers that are not in business class, so that's 1/4 of this 120. So divide that by 4, we get 30. Those 30 are also flying for the first time. They're not in business class, so they simply have to go in the first time flyer circle. That means the other 3/4 of the 120 are not flying for the first time. That's the other 90, therefore they have to go in the box here. They are not first time flyers, they are not business class, so they belong within the larger universe, which is the total number of passengers. We can check this if we add our numbers up. 90 plus 30 is 120, plus 3 is 123, plus 12 is 135. So we have accounted for all our passengers. Now question 14 part B, unfortunately I cannot fit on the same page and I need this diagram. It tells us that one passenger is chosen at random, and we are to work out the probability of that passenger being in business class. Well, we have a ratio to work out here. The number of people in business class are all the people within the B circle here. So that is the 12 plus the 3. So it's 15 out of a total number of passengers, which is 135. So the probability of a random passenger being selected and that passenger being in business class is 15 out of 135. If we give our answer in its simplest form, both the top and the bottom of this fraction will divide by 15 and we get the answer 1 out of 9. Question 15 is about coordinates. It tells us a line has the equation y equals x plus 3. I'm going to draw that out again at the bottom here. Y equals x plus 3. First of all, we are asked to write down the coordinates of the point where this line intersects the y-axis. Well, the y-axis goes through the line x equals 0. So if you were to put 0 in for x, you would have y equals 0 plus 3. So where x is 0, y equals 3. And as that is the y-axis, our answer is 0, 3. Let's move straight on to 15b. I'm going to write out the equation again. Y equals x plus 3. And we're to write down the coordinates where the line intersects the x-axis. Now this is similar. The x-axis is the line where y equals 0. So we have 0 equals x plus 3. Therefore, if we move it round, we have 0 minus 3 equals x. Therefore, x equals minus 3. So, not forgetting to put the x coordinate first, we have minus 3. And we know it's the x-axis, so y equals 0. And those are your two answers. Question 16. The graph below is used to convert between temperature in degrees Fahrenheit and degrees Celsius. And we're asked to use the graph to convert 40 degrees Fahrenheit into degrees Celsius. So this is just a matter of reading the graph. So Fahrenheit is along the horizontal axis here. So Fahrenheit 40 is here. If we read up to the line here and read across to the Celsius scale, which is the vertical line, it is, in my eyes, about 4 degrees Celsius. Now, for questions 16b and 16c, we are going to have to go back to that graph, which is unfortunately on a different page. So let's look at the information we need first. We are told there is a temperature, which they're going to call T, where the number of degrees Celsius is double the number of degrees Fahrenheit. Now, we could look back at the graph and start to search for that position where one is double the other. But we are first of all told to draw the graph of C equals 2F. So we're going to draw a line where this value is true, and it will help us to find the point on the original graph. So let's first of all complete this table, given what we're asked for here. On the table, we have to draw in C equals 2F, for the values minus 5 to 25? Well, they've started us off. Minus 5, 2 times minus 5 is minus 50. If we go to the other extreme, where Fahrenheit is plus 25, 2 times 25 is plus 50. And I guess you could use the center point here by putting in the halfway point. If Fahrenheit is 0, then 2 times F is also 0. So we have these coordinates. We have minus 25, minus 50, 0, 0, and 25, 50. So I'm going to go back to the graph and put in that line. Now we're going to use this to estimate the value of t. Now let's have a look at that once I've drawn the line into the graph. So let's plot those 3 points that we had. It was minus 25, minus 50, which, if we're really careful, is just there. It was 0, 0, which is there, and it was plus 25, plus 50, which is just there. We now need to join those points together, and if we do that, we end up with a line which looks like this. Now, we are asked to find or to estimate the point on the original graph, on the conversion graph, where one value is double the other. Let's have a look at what this tells us. The blue line is the line where Celsius is double the value of Fahrenheit. We are wanting to know the point along the conversion line where the same is true. Therefore, it has to be the point where both lines meet. And as an estimate, as clearly as we can read it from my graph, it is at the point minus 12, minus 24. Question 17. In a bag there are 10 pence coins, 20 pence coins and 50 pence coins. We are told there are 2 fewer 20 pence coins than 10 pence coins. And also there are 5 more 50 pence coins than 10 pence coins. And we're asked to complete the table. Let's have a look what the table's already telling us. It's telling us that the number of 10 pences, we are just going to call it n. That is how many 10 pences there are. The first line tells us there are 2 fewer 20 pence coins than 10 pences. So however many 10s there are, n, there are 2 less. So that's n minus 2. Now the bit that we're completing tells us there are 5 more 50 pence coins than 10 pence coins. So let's use the same terminology. The number of 10 pence coins is n, but we know there are 5 more 50 pences, so that is going to be n plus 5. That's part A. Part B is saying altogether there are 60 coins. And we are to work out the total value of the 20 pence coins. Part B tells us that altogether there are 60 coins and we have to work out the total value of the 20 pence coins. Well, to do this, we need to know the value of n. Let's see what we have. We know 10 pence coins, we have n. We also know 20 pence coins, we have n minus 2. So let's add them together, n plus n minus 2. Also in the bag, there are 50 pence coins, and there are n plus 5 50 pence coins. We know the total number of coins is 60, so all these must add up to 60. Let's collect things. N plus n plus n, we have 3n. Number-wise, we have plus 5 minus 2, that is plus 3, and again, that equals 60. Move things around a little bit, that means that 3n equals 60 minus 3, moving the 3 to the other side of the equation, so 3n equals 57. Again, moving the 3, we then have n equals 57 divided by 3, so n equals 19. So, now that we have a value for n is 19, 20 pences, there are n minus 2. So that would be 19 minus 2. Therefore, there are 17 20 pence pieces. So if we take 17 and we multiply that by 20 pence, we get 340 pence, or in other words, £3.40. Question 18 is a force of 180 newtons is applied to the surface of this triangle, and we've to work out the pressure. We are given pressure is force over area. So we know the force. The force is 180. So if we're going to use pressure is force over area, we need the area. So the area of a triangle is half base times height. We are given base times height is 12 times 10, and that needs to be divided by 2 because it's a triangle. So we have 120 over 2 equals 60 centimeters squared. So that's our area of our triangle. So pressure equals force over area. So pressure is 180 as a force divided by 60 as an area, and that equals 3, and the units that we're going to use is newtons per centimetre squared. Question 19. In a sport, the number of points is directly proportional to the number of wins. Directly proportional. In other words, that means the more wins you have, the more points you get. On the axis, sketch a graph to show this relationship. This can look a little bit daunting because there's not a lot of information. There are no numbers here. We do not know how many points you get for a win. Therefore, we do not know what the gradient of line is going to be. All we know is that you have no wins, you have no points. And if you get some wins, you get some points. And the more wins, the more points. Therefore, to answer this question, you simply need to draw a straight line from the origin in a positive gradient, which clearly shows the more you win, the more points you get. Your line can be steep, your line can be not so steep, but anywhere in the centre here will give you a correct answer. Question 20. Using ruler and compasses, show the region inside the grid that is less than 4 centimetres from A and nearer to B than C. And we have to label the region R. So this is a construction question. This is one of the most difficult things to do with this software, but let me have a go and see if we can do this. First of all, compasses, and I'm going to put the point of the compass on A here. We need a region that is less than 4 centimetres. Now, if these squares are all 1 centimetre, that's 1, 2, 3, 4 centimetres. So if I draw a circle there, I now know that the region I am looking for is inside that circle, because the circle has a radius of 4 centimetres, so anywhere inside that circle is less than 4 centimetres from A. If you were doing this, you would be measuring the points of your compass to make sure that they are indeed 4 centimetres away from each other. Now, the next qualification is that the area is nearer to B than C. Therefore, we're going to have to draw a perpendicular bisector of B and C. And the easy way to start that is let's draw a line from B to C. So starting on B, and again I'm trying to be as accurate as I can here, we've got B to C. Let's have a look at how we draw a perpendicular bisector. We need to move these round so that the point of the pencil is certainly over halfway between B and C, which I will make about there. And on this particular bit of software I have to draw it like this and make a circle, or a part circle, like so. I am then going to put the point of the compass on C. Let's move it round slightly, and I'll move it to here, and again I'm going to draw the arc of a circle from here. Now, if I now draw a line from this point where the two lines meet, across and through the other point where they meet, I'm going to have a line here. I'm going to go back here and I'm going to change the actual colour of the final lines. I'll leave my construction lines in blue, but the actual final lines I want to show in red so we can more clearly see the results of what we've done. So again, let me draw this line in red here. That way it's now easy for us to disregard the construction lines in blue. The important lines are in red. So inside the circle is less than 4 centimeters from A in any direction. So the region we are wanting is inside this circle. It also has to be closer to B than C. Well, we have drawn a perpendicular bisector between B and C, so everything on the top side of the line is closer to B than C. Therefore, the area that qualifies for our question is inside the circle and on the top side of the straight line. Therefore, our R is going to be in there. Question 21. Beth is driving 200 miles in 4 hours. We're told she drives the first 18 miles at an average speed of 36 miles an hour, and we're to work out the average speed for the rest of the journey. Okay, this is definitely going to be one step at a time, and although there may be a couple of different ways of answering this, I kind of feel as though I want to turn the 4 hours into minutes. Let's see how that works. So 4 hours is actually 240 minutes. Let's work on the first part of the journey. We need to know how much time that has taken up so we can work out what time she has left for the second part of the journey. We're going to use one of the triangles that we can use to help us with this kind of calculation, and this one is the distance, speed and time calculation. What do we know? We know the distance is 18, so 18 miles, and the average speed in miles per hour is 36, so distance divided by speed gives us the time. Well, this gives us 0.5. Don't forget that's in hours because it's miles per hour. So that is the same as 30 minutes. It's half an hour. If she has been travelling 30 minutes and she's now done the first 18 miles, that means that the distance remaining is 200 minus 18, so she has 182 miles still to go. Time-wise, she started out with 240 minutes. She has been travelling for 30, therefore she's got 210 minutes left. To work out the average speed, we're going to use the same triangle again, distance, speed and time. Now this time we know that the distance is 182 and the time is 210 minutes. So we have 182 divided by 210, distance divided by time. That will give us the speed. 182 divided by 210 gives us a recurring decimal of 0.8, and it's 666 recurring, so I'm going to call it 867. Now the number we've worked out here is the speed in seconds per hour. Therefore we have to take our 0.867 and multiply it by 60 to turn it back into hours, and we get 52 miles an hour. There's a slight decimal number on the end of there, but that is a result of rounding, so the answer is 52. Question 22. The diagram shows rectangle ABDE and right angled triangle ABC. We know that AC is 17 and BC is 8. They're both drawn on the diagram for us. We're also told there's a ratio between BC and CD of 1 to 2. And we're to work out the area of the rectangle. So we need to know both sides of the rectangle. Well, the bottom side is probably the simplest. If we have a ratio here of 1 to 2, then if BC is 8, then CD must be 16. So therefore, this side of the rectangle is 24. We'll save that for later. Now, let's have a look at this triangle. We have the length of the hypotenuse and one of the other sides. We're going to apply Pythagoras. Let's just call AB x, just for simplicity. So, what do we know about Pythagoras? We know that the square of the hypotenuse is equal to the sum of the squares of the other two sides. If you were to write that, that would mean that x squared plus 8 squared equals 17 squared. So if we move that around a little bit, that means that x squared equals 17 squared minus 8 squared. One for your calculator. 17 squared minus 8 squared tells us that x squared is equal to 225. Therefore, we need to find x. Therefore, we need the square root of 225, and that is 15. So x is actually 15. We therefore have two sides of the rectangle. We have 15 and we have 24. So to find out its area, it is simply 24 times 15, and that gives us 360 centimetres squared. Question 23. In a sport, injury time is time played at the end of a match. The table shows the injury time in T played in 380 matches. So here we've got a table. We're asked to circle two words that describe the data. Well, continuous and discrete are different types of data. Let's have a look which this is. Discrete data is that which has gaps. It has distinct groups. Maybe you're looking at shoe sizes. You might be a size 7 or a size 8 or a size 9, but you're not a size 7.1, 7.2, 7.3. There are gaps between the information. Continuous, there are no gaps. Now look at this table. It goes from 0 to less than or equal to 2, and then immediately continues with greater than 2, equal to 4, greater than 4. There are no gaps between these different groups. Therefore, the information is continuous. Is this information grouped or ungrouped? Well, each interval has a period. It is grouped. The first one is between 0 and 2. So it includes anywhere within those two numbers. It's a group of information, therefore it is grouped. Question 23b, which class interval contains the median? You must show you're working. Well, to show you're working, I think there are 380 matches. The median would be the halfway point. So if we divide that by 2, we get 190. So we are looking for the 190th entry here. The first table has 59. We add to it 158, and we have reached, if I add those together, 0, 2. So already by the time we have got to the second interval here, we have passed 190 and got up to 207. So the 190th must be in this interval here. Now we have question 23c, and again I can't fit it on the same page. What 23c is asking us is what percentage of these matches has more than 6 minutes of injury time. So let's have a look. The first interval only has up to 2 minutes, up to 4 minutes, and up to or equal to 6 minutes. Our fourth interval is above 6 minutes, and therefore so is the last interval. So all these matches in the last two intervals had more than 6 minutes injury time. Therefore it's 45 plus 12, so we have 57 matches had more than 6 minutes. So that's 57 out of 380. That's a fraction. We are asked to turn it into a percentage. 57 divided by 380 equals 0.15, and if we times that by 100, we get 15%. So although it's not on the page, it's just below. That is the answer to 23C. Question 24, we're told that x is an integer, in other words a whole number, and we're given two inequalities which describe x, and we have to work out all the possible values. So we're looking at those values of x which appear in both of the inequalities. So let's have a look at the first one. We're told first of all that x is greater than minus 4, so it can't be minus 4, but it could be minus 3 and minus 2, and let's continue, minus 1, 0, 1. And if we look at this, it is smaller or equal to 2, so it could also be 2. Let's take a look at the second inequality. We're now told that x plus 3 is greater or equal to 2 and is smaller than 9. We need to get rid of that 3. We need to know what x is smaller or greater than. So let's just rewrite that. So we have 2 smaller or equal to x plus 3, which is smaller than 9. Now to remove that 3, we need to take 3 away from the centre section here. So we have to take 3 away from all parts of the inequality. So first of all, we have 2 minus 3. 2 minus 3 is minus 1. That is smaller or equal to. So now we have x plus 3 minus 3. That just leaves us with the x is smaller than 9 minus 3 is 6. So now we have an equality with just x in the centre. Let's write the possible values of this one. Well, minus 1 can be equal to, so it's minus 1. And then 0, 1, 2, 3, 4, 5, not 6. It's smaller than 6 but not equal to. So with two sets of values here, we need to look at the ones that appear in both. Minus 3 doesn't, minus 2 doesn't, minus 1, 0, 1 and 2 are both in both these equalities. 3, 4 and 5 are not. So our answer for the possible values of x are minus 1, 0, 1 and 2. Question 25 brings us into a ratio question. Joe and Kyle share the amount of money in the ratio 7 to n. Joe gets 35% and we need to work out what n is. Well, it is a ratio, so we've got Joe and Kyle. So let's put the ratio of the percentages down. Joe is getting 35%. So if Joe's getting 35, that must mean Kyle is getting the other 65%. That's 100 in total. So there's our ratio. And in fact, if we look at this ratio, 35% is 7 parts of the ratio. We know how many parts of the ratio Joe has from the top here. So 75 is 7 parts. Look at the maths that's been done there. It has been divided by 5. So 35 over 7 is 5. Therefore, the other side of the ratio also has to be divided by 5. 65 divided by 5 is 13. Therefore, n equals 13. Question 26. Circle the reciprocal of 4. Well, a reciprocal is a number that you would multiply by 4 to get the answer 1. So it's 4 times something equals 1. And the simplest way to do this, to work out a reciprocal, is to simply multiply by its inverted self. In other words, 4 times 1 over 4 equals 1. A quarter of 4 is 1. So we have to find which of those decimals is equal to a quarter, and of course it's 0.25. Question 27. Ratio again. The ratio of x to y is 1 to 3. We're being asked to circle the correct equation that gives us this. Well, let's have a look at this. It means whatever x is, y is 3 times bigger. So y is 3 times x. Y equals 3 times x. And finally, we reach question 28. It's a linear sequence and we're told it starts 11, 21, 31, 41. Work out the expression for the nth term. In other words, the expression for this sequence. Well, first of all, we look at the gap. It is going up by 10. Therefore, the expression starts 10n. We then need to establish where the minus 1 term is. Don't forget this is term 1, this is term 2. We are looking for the minus 1 term to establish the expression. If we take 10 away from 11, we end up at plus 1. So on the end, we put plus 1. Therefore, your expression is 10n plus 1. I really hope you found this video useful. The subscription button is appearing at the bottom right hand side now, and I would be grateful if you'd subscribe, and hopefully you will find some of my other videos just as useful. Thank you for watching.